All right, welcome to section 1.5, part 1. The title of the section is Parent Functions and Transformations. In this particular video in part 1, we're only going to talk about parent functions and what those are and what they look like. Okay, so what we're going to learn how to identify, graph, and describe parent functions. So really we need to know what a parent function is. So let's look at these two definitions, and hopefully this will help us come up with what a parent function really is. Okay, so this first definition says a family of functions is a group of functions with graphs that display one or more similar characteristics. Okay, so let's say we have an xy plane here. We're going to draw some, let's pick out one particular shape, so parabolas. Okay, so parabolas could be very skinny. Okay, parabolas could be very fat. Okay, parabolas could be upside down. Okay, these are all parabolas. They could be, upside down again, shifted to the right, shifted to the left. Okay, they could be up here with no x-intercepts. Okay, these are all parabolas, but they're in the same family. They're different parabolas, but they're in the same family. So that's what family of functions are. These are all parabolas are a family. All right, now what is this word parent function that I talked about a little bit ago? A parent function is the simplest of the functions in a family. Okay, so for instance, for parabolas, the parent function is just y equals x squared, because parabolas are always x squared graphs. Now, this is the parent because it's the simplest. What could I do to not be a parent? So I could do like x squared plus 1. That's the parent, and it goes up 1. I could do y equals negative 3x squared. I could do y equals x minus 4 squared plus 6. I could do ax squared, so 3x squared plus 4x minus 7. Okay, so these are all parabolas because they're x squareds. But the only one that is the parent function is the one that's the simplest. Okay, this is just y equals x squared. All right, so what we're going to do in the next few pages is basically look at the 7 parent functions that we're going to discuss in this first chapter. All right, so we're going to look at the first one here. The first one is called the constant function. So the equation is f of x equals c. C stands for constant. So really, you could do y equals c. Okay, so f of x is just equal to y. And c can be any real number. So let's do y equals 2. Okay, so that's what we're going to do. We're going to do y equals 2. So I'm going to make an xy table. Okay, and it's telling us that y equals 2 no matter what. Okay, no matter what we do, y is equal to 2. So my whole y column is going to be 2 because this is y equals 2. So I'm just going to do, I'll do negative 2, I'll pick 0, and I'll pick positive 2. All right, so let's see what this looks like. Negative 2, 2. So 2 to the left, 2 up. Okay, there's 1. 0, 2. 0, 2 is right here. Remember, these are just ordered pairs that we plot on our graph. And then I did 2, 2. So 2 to the right and 2 up. So notice that we have a line. All right, so I'm going to draw a line through it. And there is our line. Now, it is a horizontal line, so if you want to write this down, so constant functions are horizontal lines through y equals to your c. So our c for this one happened to be 2, so it went through positive 2. All right, so constant functions are probably the least common that we use, but it is one of the parent functions. So constant functions are horizontal lines through y equals c. All right, so let's do the identity function. A lot of times this is called the linear function, which means straight line. The last one is a straight line, but these are diagonal lines. So f of x equals x, so we're just going to use y equals x. We're going to make an xy table again. And 90% of the time, we always use the numbers negative 2, negative 1, 0, 1, and 2. And we use that to build our chart. All right, so let's see. If I plug in negative 2, so y equals negative 2. All right, negative 1. Y equals negative 1. I get negative 1. If I plug in 0 for x, I get y equals 0. If I plug in 1, I get 1. If I plug in 2, I get 2. All right, so then we're going to plot this, and we'll see what this looks like. So negative 2, 2, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2. You probably see that 3, 3 would be 1, or 4, 4 would be 1, negative 3, negative 3. All right, so this is a straight line again, and it is called the identity function. All right, so it's a straight line that goes right through the origin. All right, so that's what that looks like. All right, so that's called an identity function, y equals x. All right, number 2 is the quadratic function. So this is the one we just talked about a little bit ago. So y equals x squared is the parent function for parabolas. So let's use our xy table again. So negative 2, negative 1, 0, 1, and 2. Let's plug it in. So negative 2. So y equals negative 2 squared. I'm plugging it in for x. So you see that that's negative 2 squared is 4. So next one is y equals negative 1 squared. So that equals negative 1 times negative 1 is 1. 0 squared is just 0. 1 squared is 1. And 2 squared is 4. All right. So we have 5 ordered pairs here. Let's plug this in. So negative 2, 4. Negative 2, 4. Negative 1, 1. 0, 0 is just 0, 1, 1, and 2, comma 4. And so I'm going to try to draw this on the computer. It's a little bit harder to do. We'll do our best here. So parabolas are rounded. And make sure you put your arrows. All right, so there is our parent function of the parabola. All right, so that's y equals x squared. All right, next one is called the cubic function. So y equals x cubed. Okay, let's do the same thing. xy, negative 2, negative 1, 0, 1, and 2. So negative 2 cubed. So y equals negative 2 cubed. So that's negative 2 times negative 2 times negative 2, which is equal to negative 8. Negative 1. So negative 1 cubed is negative 1. 0 cubed is just 0. 1 cubed is 1. And 2 cubed is positive 8. All right, so let's plot this one. Let's see what we get here. All right, so negative 2, negative 8. So all the way down here, negative 2. Negative 1 is equal to negative 1. So it's kind of right in the middle here. Then we have 0, 0, 1, 1. And then last one is 2, comma 8. All right, so this one's a little bit harder to draw. Let me go down a little bit. All right, so what does this look like? All right, and then there is our cubic. So we have those 5 points. All right, so there's a cubic. It's kind of like a sideways S. Okay, so that's the parent function for cubics. Now these could change. They could change size and shape. But if we're just talking about strictly the parent function for cubic, y equals x cubed, that is what it's going to look like. All right, next one is called the square root function. All right, so y equals square root of x. Now for this one, the table, we're going to do this one a little differently because so remember, square roots cannot be negative. So we're going to start at 0, we're going to do 1, we're going to do 4, and we're going to do 9. And why am I choosing that? Because I want to choose numbers that are easy for my equation. So this is a square root. These are all perfect squares. So y equals square root of 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. All right, so let's see here. So 0, 0, 1, 1 would be kind of right in the middle here. 4, 2, and 9 would be 3, which is kind of like right here. All right, so we want to connect these dots here. I know Mr. Clark calls this the freestyle swimming function because it kind of looks like a guy swimming. I don't know where to get that from, but I do kind of see it a little bit. But that's the square root function. Okay, that's what the parent function looks like for the square root. All right, I believe we have 2 more left. This one is called the reciprocal function. This one is y equals 1 over x. This one's going to take us a little bit more work to get. So let's see here. So negative 2, negative 1, 0, 1, and 2. So negative 2, 1 over negative 2 is negative 1/2. Negative 1, so 1 over negative 1 is just negative 1. 1 divided by 0. Hopefully you see that that is undefined. If that one does not work. 1 over 1 is just 1. 1 over 2 is 1/2. And let's plug in these numbers here. So we have negative 2, negative 1/2. That's about right there. -1, -1. 0, 0 doesn't work. That's undefined. 1, 1 is our next one, and then we get 2, 1/2. Now, I don't know about you, but I don't see the pattern here. I don't see what I can do to graph this one. So what I'm going to do is I'm going to continue on, and I'm going to choose more numbers to see if I can get a better look at what's happening here. So I'm going to do -3 and +3. So I'm going to go one more to the left and one more to the right. So this one will be -1/3, and this one will be +1/3. Oops, not that. All right, so -3, -1/3. That's right there. +3, +1/3. All right, I still am not quite sure. So I'm going to try a number in between 0 and 1. So let me try 1/2. I'm going to try 1/2, see what that's equal to. So 1 divided by 1/2. Really, that means multiply by the reciprocal. So 1 times 2/1. 1 times 2 is equal to 2. So 1/2 is equal to 2. And what do you think -1/2 would be? Hopefully you see that it would be equal to -2. So now I can kind of see here what I got going on. I have what's called a hyperbola that we'll learn more about in PreCalc B, but it looks like this. And notice that we have a vertical asymptote at 0 and we have a horizontal asymptote at 0. So this graph can never be equal to 0 because it's undefined. Okay, so that is our parent function for reciprocals. All right, and then the last one we have is the absolute value function. This one's pretty easy. Y equals absolute value of x. So xy, -2, -1, 0, 1, and 2. So what is the absolute value of -2? +2. So all of these just turn into positive. Okay, and let's plot them. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So this kind of looks like a parabola, but really these are straight lines. These are, so absolute values are V-shaped graphs. Okay, so there's the parent function for absolute value. All right, so now what do we do with all of these parent functions, these different graphs? Okay, so there are a lot of important properties that we've learned in sections, okay, sections 1.1 through 1.4. We learn about every single one of these. All right, so we should be able to, or you should be able to tell me the answers to all of these properties for each one of these graphs. All right, so that's what we're going to talk about later. All right, so hopefully these parent functions make sense. They're the simplest graphs, and these are just charts to kind of explain them a little bit further, a little bit more than what I did, a little more complicated as well. But that's section 1.5, part 1. I will see you tomorrow. Have a good night.